So does race cars. I mean, if you look at a race car, particularly if you look at the tail region of a race car, right? So what I mean is regions over here. If you look at what I have circled on the, this is basically a staggered set of two airfoils. Okay, if you look at the cross section of the two airfoils, they are something like that. I mean, the reason is that the race car, if you look at it, I mean, this is not the only airfoils. You also have a even more set of staggered airfoils in front of the car. The race car is essentially an airplane flipped over. If you look at the airfoils, they are the opposite of the airfoils on the airplane. And the purpose is to generate lift in the downward direction. Okay, this is called downforce in racing. If you have enough downforce, you can really turn at a much higher rate than if you don't. Almost all the race cars in Formula One, they can pretty much drive upside down, right? I mean, if you drive the race car in the tunnel, and you can really flip over and drive on the ceiling of the tunnel, because the downforce it generates, it's several times higher than the weight of the car. And this is how powerful these lift forces are generated by these airfoils. Well, the same kind of a mechanism is generating the lift of helicopters. If you look at helicopters, you may say it has rotors, but what is a rotor? It's a set of several wings, right? And each wing is, of course, formed by a bunch of airfoils. And actually, for helicopter rotors, the two-dimensional analysis is actually extremely accurate, exactly because the rotors are generally very elongated. So the two-dimensional assumption actually holds pretty well for helicopter blades. Of course, what works for helicopters also works for propellers, right, on an airplane. The propellers is essentially just similar as helicopter blades, except for they are a little bit shorter, a little bit more kind of less elongated. So they are again formed by a set of airfoils with different shape, different angles of attack. So you see the twist on the propellers.